Let us have a look at the forces and torques acting on the wheel during slipping with the help of animation of a bicycle wheel. It is the torque or the twisting force produced by the engine, and in this case the rider, which moves the wheel. Wheel is set in motion by the force which it applies against the surface. This is also known as traction. Wheel slips when the force applied to the wheel or the torque produced by the engine, in this case the rider, exceeds the traction available to the wheel with the surface on which it is running. This is the circuit diagram of wheel slide protection system. The red and white lines are electrical connections, while the blue lines are pneumatic connections. The speed sensors are provided, one per axle, at the outer box cover. The speed sensor gives unidirectional input to the microprocessor control unit. Based on these speed inputs, the microprocessor control unit provides instructions to the anti-skid valve. The anti-skid valve has an exhaust port and it is operated with the aid of a solenoid. It is placed between the connection of distributor valve and the brake cylinder. Based on the instructions provided, the anti-skid valve regulates brake cylinder pressure. The parameters in threshold speed criteria. Upper threshold speed V1. It is the speed above which axle involved is losing adhesion. Reference speed VR. It is the indicative speed of the vehicle and is taken as the speed of the fastest axle. Lower threshold speed V2. It is the speed below which the axle involved is considered to be skidding. DEC. Deceleration criteria. It is the maximum allowed deceleration for each axle. When crossed or breached, the brake cylinder pressure is modulated. The deceleration criteria is followed when there is simultaneous loss of adhesion of all the axles. ACC. Acceleration criteria. This is a fixed value and its operation is similar to that of deceleration criteria. This is the control logic of pneumatic assembly of wheel slide protection. The brake cylinder pressure is reduced if Vi, the instantaneous velocity, is less than or equal to V2, the lower threshold speed, or Ai, which is the instantaneous acceleration of the axle, is lower than or equal to DEC, the deceleration criteria's fixed value. The brake cylinder pressure is restored or increased if Vi, the instantaneous velocity, is greater than or equal to V1, the upper threshold speed, or AI, the instantaneous acceleration is greater than or equal to ACC, which is the fixed value of the acceleration criteria. The brake cylinder pressure is maintained or remains constant if the instantaneous velocity lies within the upper threshold speed v1 and lower threshold speed v2, or the instantaneous acceleration of the axle lies between the fixed value of deceleration criteria and acceleration criteria. This is the graphical depiction of working of control logic in context of different parameters involved. Graph 1 shows axle speed variation with respect to time. The parameters depicted on the graph are VR reference speed. It is the indicative speed of the vehicle and is equal to the speed of the fastest axle. V1 upper threshold speed, the speed above which axle loses adhesion. V2 lower threshold speed, it is the speed below which axle starts skidding. All these speed measurements are obtained by the speed sensor. Graph 2 shows axle acceleration and deceleration values variation with respect to time. Graph 3 shows brake cylinder pressure variation with respect to time. It is the brake cylinder pressure which is regulated by the wheel slide protection, in response to which the axle speed and axle acceleration values are altered. Graph 3. Region 1. The brake cylinder pressure is increased to apply brakes, because corresponding to it in graph 1, the axle speed is above the desired range of V2 lower threshold speed to V1 upper threshold speed. In order to bring the axle speed within the desired working range of V1 to V2, brakes are applied, resulting to which axle deceleration occurs as shown in graph 2. Graph 3, region 2. Brake cylinder pressure is maintained at constant value. That is, there is no variation in the braking, since axle speed is within the desired range of V1 to V2 as shown in graph 1. Resultant to this, the axle is further decelerating as shown in graph 2. Region 3 of graph 3. Brake cylinder pressure is constantly decreasing. This implies the brakes are released. It happens in spite of the axle speed being within the desired range of V1 to V2, because now the axle deceleration value has exceeded the set value of deceleration criteria as shown in graph 2. Region 4 of graph 3. Brake cylinder pressure is constant because both axle speed and axle acceleration are within the desired range of V1 to V2 and deceleration criteria value to acceleration criteria value respectively. Region 5. Brake cylinder pressure is reduced. That is, the brakes are released. This is in response to the axle speed getting lower than the lower threshold speed V2 as shown in graph 1. Region 6 of graph 3. Brake cylinder pressure is constant, since corresponding to it the axle speed is within the safe working range of V1 to V2 and axle acceleration value is also within the safe working range shown by lines of DEC and ACC on graph 2. Region 7 of graph 3. Brake cylinder pressure is increased. That is, now the brakes are applied. This is to arrest axle acceleration which has exceeded the set value of the acceleration criteria as shown in graph 2. In this case, the axle speed is within the safe working range. Region 8 of graph 3. Brake cylinder pressure is constant, since axle speed and axle acceleration, both the values are within the desired and safe working range. Region 9 of graph 3. The brake cylinder pressure is increased. That is, the brakes are applied, because axle speed has exceeded the upper threshold speed, resultant to which the axle decelerates as shown in graph 2.